And welcome back to another fantastic episode of Space Nuts. This is the podcast that is out of this world.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
I'm your host for this episode, Heidi Campo, filling in for our beloved Andrew Dunkley, who is still on his cruise around the world. He's been having a blast. And joining me is Professor Fred Watson, astronomer at large. And Fred, you're traveling, you're in a hotel. Tell us where you're at and what you're doing.
Yeah, I'm at large. That's right. I'm in the city of Adelaide, which is the capital city of South Australia. That's a state in the south of the country, as you might expect from the name. The name tells it like it is. And I'm here for the annual meeting of the Astronomical Society of Australia, which is the body that all professional astronomers in Australia belong to. And I think there's about 700 of us. There won't be 700 here, but there's quite a significant cohort. There was a reception last night where I saw quite a few old friends. So that's why I'm here. I'm not giving a talk as such, except that on Wednesday, for my sins, I'm the chair of the steering committee of the education and public outreach chapter of the society, and they're going to have a meeting, which I'll have to chair because I'm the chair of the committee. So I've put together a bit of a presentation on what I think this chapter should be concentrating on over the next 12 months, what the education and public outreach section of the observatory should be really focusing their minds on. They won't take any notice of me, but that's all right. That's just, me doing my bit for pushing education and public outreach in the right direction here in Australia.
Excellent. Well, that sounds like just an absolute blast. I love that you're there and you're going to be able to see old friends. And I know what this means for us is that we are going to have so many great stories and updates after this conference. You're going to be filling your brain with all the latest and greatest and sharing it with us. So that's really fun and exciting. And we do have a lot of really interesting stories to talk about today. I don't have a fun catchphrase. I think last week was histories, mysteries, and discoveries, and I don't have anything catchy today. We just have some great stories. But to kind of start it off, this is not really a story, but a little bit more of an announcement. Space Shuttle is coming back.
Apparently, and it's coming to your city as well, which is why I thought you'd like this story, Heidi. And it's part of the big, beautiful bill. Apparently, there is in that bill $85 million to move the Space Shuttle Discovery from the Smithsonian Institution down to Houston, where it's kind of going to live. I don't know what the Smithsonian thinks about this. I don't know whether they've been asked yet, but that's the idea, that it's going to come back to Houston. And we'll see what the outcome of that is. But I thought you'd be exciting, given that that's your home city. Oh, excited, given that that's your home city.
Yes. Yeah. Well, and I really am. I live just a couple minutes away from Space Center. I chose our location specifically because we wanted to live close to all the action, so I could jog there and go see it. So that is kind of exciting. I love Space Center Houston. I love Kennedy Space Center. All of these places are such a fantastic way to just, I think every single one of our listeners who's been to one of these places feels that visceral pull of, wow, that's when I really started falling in love with space. So it's exciting to have all of these things in one place where they can be cared for and the education can be there and it's all space related.
Yeah.
So that's really kind of exciting. But our first story today is one that I am very curious about. I even mentioned this to you before we started recording, but it looks like the third ever confirmed interstellar object coming through our solar system, which is so strange to me because I'm like, wait a second, there's stuff coming, zipping around all the time. So what is this third ever? like confirmed? And what is this object? Tell us about this, Fred.
Well, that's a great question, actually, because nobody's really quite sure. It looks like a comet, and comets are different from asteroids in that they're made principally of ice. And when the ice gets near a star like the sun, it starts to turn into a gas, to water vapor, essentially, bringing with it some of the other chemicals that are embedded in the ice in the cold of space. So yes, but you're also right that the stuff zipping around all the time around our planet, the material that we sometimes regard as hazardous, near-Earth objects, we're now concentrating on those very heavily because we know that maybe one day there will be an impact with the Earth and we need to do something about it. That's a different story. This is certainly not in that category. But there are three objects which are now known to have come from outside the solar system. And what tells you that they've done that, and in the particular case of this new object, which is called 3I, which means it's the third interstellar object, Atlas, which is an acronym for the name of the facility that discovered it, which is down in Chile. So 3I Atlas has a velocity which is something like 61,000 kilometers per second. And that's, am I talking rubbish here? 61 kilometers per second. I'm thinking about kilometers per hour.
I had to check your math.
Yeah, that's right. It's about 60 kilometers per second. Whereas things that are part of the solar system, and some of the comets that whiz in from the Oort cloud, this cloud of debris that we think surrounds the solar system, some of them achieve quite high speeds, but it's never more than about 40 kilometers per second. And this thing's 50% higher than that. And the other clue that tells you that it's from outside the solar system is the shape of its path around the sun, the shape of its orbit, because it's not an orbit that's closed in the way we normally think of orbits. It's an open orbit. It will only go past the sun once. You might be familiar with the term eccentricity, Heidi, which is the measure of the shape of an orbit. So if you've got an orbit that's perfectly circular, it's got an eccentricity of 0. Anything bigger than 0 and less than 1 is an ellipse, and the eccentricity number tells you how flattened or how squashed the ellipse is, how elongated it is. When you get to 1, you've got a parabolic orbit. That's one that just comes in from infinity and heads off back to infinity after it's gone past the sun. This one has an eccentricity of more than 6. And that's a huge number. And it tells you that it's got to have come from outside the solar system. Nothing inside the solar system could have an eccentricity as high as that. So it's all about the orbital details. It's going to pass closest to the sun in October. So we're still seeing it on its inward path towards the sun. Unlike the most famous, the first of the interstellar objects that we discovered back in 2017, Oumuamua, a Hawaiian word meaning first visitor from afar, because it was discovered in Hawaii, on Haleakala, in fact. That one was thought to be a few meters across. It's really still not certain what shape it was. It was thought to be like a cigar at first, an elongated shape, but it's now perhaps thought to be more like a dinner plate. But we didn't discover that until it was actually on its way out of the solar system. It was only seen after it passed its closest to the sun. This one, 3I Atlas, is still on its way in. And it's got a slightly fuzzy appearance, and that tells you that it is probably made of ice. And what it's doing is actually releasing, as it gets near the sun, the ice it's not melting, it's subliming. Subliming means it's turning straight from a solid to a gas. And it's releasing some of the dust that's embedded in the ice. And that's what's giving it that fuzzy appearance at the moment. But it is possible that we might start seeing plasma ejected, which might tell us about the constituents of its icy core. Where did it come from? We don't know. There's some work been done that suggests that our nearest star system, Alpha Centauri, could in fact basically eject interstellar material around the whole vicinity of the sun, not necessarily the direction that this thing's come from. We don't know whether it's come from Alpha Centauri or where it's come from. But it is certainly going to be the subject of intense study. The world's telescopes are already focused on it. I'm sure the Webb telescope will get some time looking at it, and we might discover things that we really don't have any other way of finding out. This is a sample of material that has come from another solar system. And so it could have quite different physical characteristics, quite different chemical makeup. That's all the sorts of questions that are arising about this object. So I'm sure that you and I, or maybe you, maybe me and that other, what's that other person called? Oh, Dunkley, yeah. Maybe maybe Andrew and I might talk about it if you and I don't, because I think it will crop up again in the news and certainly be on Space Nuts Horizon.
So what is the difference? At the risk of sounding silly, I'll just ask this because I'm sure someone else has this question too. Something like Halley's Comet is that not considered then one of these three objects?
No, that belongs to the solar system, and that's because it's got it actually is in orbit around the sun. It has an orbital period of 76 years, if I remember rightly, which means it's actually what's called a short period comet. Anything less than 200 years, I think, is a short period comet. But this thing is different in the sense, and in fact, all the interstellar objects are different in that they only go past the sun once, and they've got this very strange orbital path, which objects like Halley's Comet.
So it's never coming back. This is one and done. No. Take a look at it, and it's gone.
That's right, exactly. And that's a characteristic of things from other solar systems. They whiz by, and you think, "What was that?" But we're now. The thing is, and there's an interesting. Postscript to this story, which I should mention, and that is we talked, I think, a couple of weeks ago about the Vera Rubin Observatory and the new telescope there that is going to revolutionize discovery rate of asteroids and things of that sort. That's going to find far more of these interstellar objects because it's so good at discovering things that are moving, through the solar system. Most of the things it'll discover belong to the solar system, the asteroids that are in the asteroid belt between the orbits of Mars and Jupiter, and also the nearer ones, what we call the near-Earth objects. But it will find things that don't belong to the solar system. And so we might go very quickly from a sample of 3 interstellar objects to tens or maybe even hundreds of them that we are able to study.
Yeah, because it takes its samples every 3 days, right?
Yeah, it does the whole sky every 3 days. It's phenomenal. Yeah,
it's incredible.
Let's take a breather from the show for a moment to tell you about our sponsor. If you're travelling soon, like I am at the moment, and you're tired of paying ridiculous roaming fees, say hello to Saily, S-A-I-L-Y. It's the easiest way to stay connected abroad with just a few taps. Now, Saily is an eSIM app that gives you fast, secure and affordable mobile data in over 190 countries. There's no physical SIM. You don't have to pop yours out and put another one in. No surprise charges. You just download, install and connect all from your phone. It's very secure, very easy to use. Your privacy is also locked down. You can enjoy the benefits of ad blocking, virtual location, secure browsing, and that's all free with every plan on Saily. Now, whether you're working remotely, streaming on the go, or just posting beach pics, Saily has you covered. And here's the deal. Go to saily.com/spacenuts and use the code spacenuts for an exclusive discount on your first plan. That's saily.com/spacenuts and use the code word spacenuts. You won't regret it. It works really, really well. It's fast, it's efficient, it's secure. That's saily.com/spacenuts. Now back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Oh, we really are in such an incredible age of discovery. Everyone who is alive right now, I hope we recognize how incredible it is to live during this time, because there's so much to discover. And there's so much for us to, every single day, we're learning so much more about the universe. And that is apparent with our next story, with the New Horizons conducting the first ever successful Deep Space Stellar Navigation Test. That sounds like we're really on the cusp of some exciting
Yeah,
things.
I think that's a great way to put it, actually, because it's a spacecraft that you probably remember. It was launched in 2006 for an encounter with the dwarf planet Pluto, which took place in, if I remember rightly, it was July 2015, when it flew by Pluto and revealed what an astonishing world Pluto is. But since then, it's been on its outward journey. It flew by an object called Arakoth and gave us an impression of that, probably images of that some 3 or 4 years ago, I think now, and is sort of on its way. It's one of the 5 objects that will leave the solar system. So they will head off to the wide blue yonder. These objects will almost certainly outlast humankind and maybe even outlast our planet, because there's nothing to stop them when they head off that way. Anyway, New Horizons was equipped, unlike the Voyagers and the Pioneers, which were products of the 1970s and are still on their way out of the solar system. New Horizons had some quite sophisticated technology on board, and in fact includes effectively a telescope, which can be used to measure the positions of stars. That's a science that we call astrometry, the measurement of star positions. And that has actually been used now to do, as you said, a navigation test, a stellar navigation test. Because it's so far from our planet, it's about 9.2 billion kilometers from Earth, and effectively from the sun, because our 150 million kilometers from the sun is a tiny distance compared with 9 billion kilometers. But it's so far from Earth that it can now measure star positions that are significantly different from their positions as measured from Earth. And by significant, I mean, I don't mean they're degrees away in the sky. They're, a few arc seconds away. That's a small angle of 1/3600th of a degree. But they're different position. They appear in different positions in the sky than they do from Earth. And this is the phenomenon that we call parallax. It's the fact that if you look at objects from one vantage point and then from another, they appear at different angles, and that is the parallax angle. It's how our eyes work as well. That our eyes, because we have 2 eyes, they detect the parallax between them, which gives us the 3D view of our environment. That still blows my mind, that our brain can take 2 separate images and make it into a 3D model of what's surrounding it. Fantastic stuff.
What I hate about that, and as soon as I say it, all of our listeners are going to be so mad at me. You usually don't notice your nose.
Yeah.
Until you do. And then it's like, whoa, what is this thing in my field of view?
Yeah.
It's like, your brain kind of overrides it. And then if you notice it, it's like, whoa, it's right there on my face.
It is, yeah. And when you get to a certain age, there are hairs sprouting out of the end of it that you
I
find
bet that's
very
really
annoying.
Fun. You see a whole new hair. You're talking to somebody, you're like, wait a second, what is that in my field of view?
But you're right. So, as you know, the nose is very nearby. In fact, our brain, exactly as you said, it kind of rules it out. So, I've seen that before. I know what that is. That's fine. But yeah, this 3-dimensional model from stereoscopic vision is effectively what New Horizons is doing. It's giving us an eye on the Earth and an eye 9.5 or 9.3 or whatever it is billion kilometers away, and that's big enough to make an appreciable angle. And so they've measured the distance using this technique to 2 relatively nearby stars, Proxima Centauri, which is part of the Alpha Centauri system we were just talking about a few minutes ago, 4.2 light years from Earth, and a star called Wolf 359. It's in a catalogue of stars by Herr Professor Wolf, I guess. That's about nearly 8 light years away. So these are nearby stars. In fact, there are 2 nearest stars apart from the sun. And it's measured their distances, and sure enough, the stellar parallax gives you the right answer. So it's I think the spacecraft is doing a fine job of finding things to do while it journeys through it's approaching interstellar space. It's still in the solar system, still in the outer reaches of the solar system, but heading to interstellar space.
Oh, that's so cool. I love learning all of this stuff.
0G, and I feel fine.
Space nuts.
Um, and our last story of the day, this is the one that everybody's gonna go crazy about. So these are the questions that I just think there's something that humans are inherently fascinated by. We're fascinated by the things that we understand the least sometimes. The biggest mysteries attract people the most. And that is, if I were to summarize the Space Nuts listeners, this is what they get obsessed with. So buckle up, everybody, because we are talking about dark energy. And we are talking about the story today. The headline reads, "If dark energy is decreasing, is the big crunch back on the menu?" So if you have not heard what the big crunch is before, Fred's going to give us a recap, and then we're going to be talking about how exciting this actually is.
Indeed, that's right. So, I mean, it's almost like Back to the Future, is this? Because when I was a young astronomer back in the 70s and 80s, we were we knew since 1929 that the universe is expanding. That was Hubble's discovery, and we attribute that to some sort of event that took place. We now think about 13.8 billion years ago, which we call the Big Bang, because we can't think of a better word for it. So back in those days, we knew that was the case, but astronomers were fairly convinced, I think, that the expansion of the universe was slowing down, even though they hadn't got the measurements to prove that. They expected the expansion of the universe to slow down because of the gravitational pull of everything in it, like galaxies and planets and stars and podcasts. All of that stuff's got gravity, and they expected that would slow down the expansion of the universe. And some astrophysicists, cosmologists really is the correct term. They're the scientists who look at the history and evolution of the universe as a whole, not just things in it. Some cosmologists thought that the slowdown might eventually result in a switch over from an expanding universe to one that's contracting, because the gravity is starting to pull everything back together. And there was the idea that perhaps at some time in the distant future, there might be what came to be known as the Big Crunch, which is everything smashing together again in a kind of inverse of the Big Bang. It's the Big Bang played backwards. And in fact, Brian Schmidt, one of my colleagues, whose name will crop up again in a very short time, he used to call it the Gnab Gib. Because it's the Big Bang backwards. So Gnab Gib is the Big Bang backwards.
And that would kind of be like a rubber band then.
Yeah, that's right. Yeah, the rubber band expands, and then, if you let go, it contracts. That's basically the mechanism for that. So,
and then in theory, then would it be exponentially? So it's like as it starts to contract in, it starts to move faster as it comes closer back to that main point.
That's exactly right. And it would be, you can imagine the Big Crunch or the Gnab Gib would be quite a catastrophic event for the universe as a whole. It was thought to be something that would happen billions of years in the future. But that was all dashed in 1998 when Brian Schmidt of the Australian National University and Saul Perlmutter in the United States, they led two teams that discovered that the universe is not slowing down in its expansion. It is actually accelerating. And that's that acceleration of the universe we attribute to something called dark energy, which is one of the biggest mysteries in the whole of science. We don't know what it is, but in the mass energy budget of the universe, it makes up 70% or so of the mass energy of the universe. So that sort of poured the cold water on the Big Crunch idea until now, because it looks as though, from evidence coming from a telescope, principally from a telescope in Arizona, one very similar to our Anglo-Australian telescope here in Australia, it looks as though the acceleration is slowing down. So yes, the universe is expanding. Yes, the expansion is still getting faster and faster, but it looks as though in the future, it won't be expanding as fast. In other words, the acceleration itself is slowing down, and it's not a constant. And that means that dark energy has different properties from what we thought it had. And that's what set off this chain of research by the scientists whose work we're reporting on now. They're at Cornell University and other universities around the world. They've looked at the data that's come from various telescopes and have actually made a model of a universe that has an accelerated expansion. The acceleration slows down. Eventually, the expansion slows down and stops, and so there's a collapse back on itself. And they've modeled that to give you a universe which has a lifetime of 33.8 billion years. Now, we're already 13.8 billion years into that. So about 20 billion years' time, they are suggesting that there will be a big crunch or a Gnab Gib. And it comes not just from modeling the astrophysics. They've also looked at some of the likely subatomic particles that we might attribute dark energy to. So it's, this is very, very speculative research, it has to be said. And nobody really is yet starting to think seriously about a big crunch because that, as I said, got wiped back in the 1990s. But it could still be on the menu, exactly as that headline says. It could still be on the menu. And I'm sure as time goes on, our understanding of just how the acceleration of the universe is behaving, because it's still a difficult observation to make, whether the acceleration is speeding up or not. But once we've got more data on that, maybe models like this will have their feet more firmly on the ground, and we might get some more insights into what the future of the universe is in the next 20 billion years or so. By then, by the way, the Earth won't exist anymore because the sun will have turned into a red giant star long before that and probably melt the Earth, which is an interesting idea. That's only, that's on our near horizon. That's only 3 or 4 billion years down the track. And of course, the Andromeda and the Milky Way will have collided. All of that will have happened. But maybe the ultimate end is 20 billion years hence. And it could be another big crunch.
Well, who knows what humanity will figure out by then. I am convinced that we can continue to become masters of our planet, our solar system. What is it called? Is it the Krasnow scale? The Kardashev,
that's right.
What is it?
It's Kardashev, I think it is.
Kardashev. Yeah, the Kardashev scale.
Yeah,
and they mathematically figured it out because there's 3. I'm talking about things that I'm not quite confident on, but I believe there's 3 different levels of civilization, and they've mathematically figured out that we're not quite a level 1 civilization yet. What are we, like a 0.7? Like we're close. We're almost there.
It's based on the energy consumption, that Kardashev scale. It's based on how much energy a civilization uses, and that's a measure of how advanced it is. Now, it needn't necessarily follow, I guess, because we might discover new ways of living that don't need the huge energy demands that the Kardashev scale thinks we will. So interesting stuff. But yeah, we're not quite there yet. You're right.
Yeah. I think it says that a type 1 civilization can harness the power from their planet. A type 2 civilization can harness all the power from their solar systems. We're talking about Dyson spheres around the sun. And then a type 3 civilization, I think they're masters of space-time. So they can travel.
Yeah, I think we should just skip straight to, type 3. We forget about the others. I think type 3 is where we want to
be. we need you. You're the brains. You're the brains of this operation.
well, you're in dire straits then. Anyway, that's all right. We'll, becoming masters of space-time is certainly something that I have on my agenda, but I haven't got anywhere near it yet.
Well, until then, we'll just have to stick with the sci-fi literature out there to fulfill that, to itch that scratch, so to speak.
That's the one. Yeah, that's the way to do it.
Well, excellent, Fred. This has been a really fun conversation. I really, really enjoyed talking to you. This dark energy stuff, I know we're going to get a lot of questions rolling in this week about it. So if you guys ever do have questions on any of these episodes, any of these topics, and you are dying to have us follow up, please just jump online. It's Bitez.com, Bitez, and you can go to our Space Nuts portal and email us a question, ask us an audio question. We'll leave that link for you. And you guys, please ask away because we love to answer your questions. Every other episode, we're talking straight to you.
Sounds great.
All right, everybody. We will see you next time with a Q&A episode. Till then, take care.
Many thanks, Heidi. And you take care too.
Hello, Hugh in the studio. Hello, Fred. Hello, Heidi. Hope you're all well. Andrew reporting in from the cruise ship Crown Princess. We are halfway through our world tour. I can't believe the time has gone so fast. Since I spoke to you last, we have visited Tenerife in the Canary Islands. And Fred, I know you will particularly be keen to hear that we drove past the Teide Observatory. Mount Teide, of course, is the stratovolcano that's right in the middle of Tenerife Island, and it is one imposing hunk of rock, that thing. It is enormous. It just dominates the skyline from everywhere you look. But just across the caldera from Mount Teide, which I might add hasn't erupted since 1909, didn't feel anything while we were there, thank goodness. But the Teide Observatory, and that is quite a remarkable little facility, as you probably well know, Fred. It is, because of the altitude, it's up around 2,700 metres or something like that. It is a solar observatory predominantly, and it's one of the most significant solar observatories in the world. But they also do astronomical observations, and as I understand it, Fred, this particular observatory is operated remotely. So I've got a feeling that somewhere along the line, Fred, you've had a bit of a play around with the equipment at Mount Teide on Tenerife. I did take some photos of the observatory from across the valley with my long-range pocket camera. It's got several domes and pieces of equipment, all hidden inside white painted buildings because they need to protect them from the heat, and white is a very reflective colour, of course. But quite extraordinary. You climb up the mountain on a very windy, steep road, and all of a sudden, at around 2,000 metres, you break through the tree line, and and you're in what you could describe as a tundra desert-like environment. And there have been so many eruptions over so many millennia. There's all sorts of different coloured lava and pumice, and layer upon layer in the cliffs. You can see where the eruptions have happened over so many years. And the big 10-mile wide caldera where there used to be a supervolcano, which is no longer there, it collapsed. And now you've got Mount Teide in its place, which is behaving itself rather well at the moment, which is good. Anyway, we've left Tenerife behind us and we're heading now for Morocco. Actually, by the time I speak to you next, we'll have made several stops. We've reached the busy end of our tour, so looking forward to telling you all about that. Most of our visits between now and then will be Morocco or Spain. Of course, Tenerife is Spanish. Lovely, lovely place. Very, very popular with Germans and English people on holidays. All right, until next time, Andrew Dunkley signing off. See ya.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bitez.com.
This has been another quality podcast production from Bitez.com.